In order for all participants to hear both sides of an Aris contact, I've come up with an audio distribution setup. Here is a schematic diagram of the audio pathways. I'll introduce each component, then we'll take a look at the actual hardware and cables to hook everything together. The microphone is a Heil Goldline series GM5 with the HC5 microphone element. The main transceiver is the Kenwood TS2000. Our backup transceiver is the ICOM IC7000. These components are connected to a Shure FP33 microphone mixer. One output goes to a Sony PCM M10 digital recorder, and the other output goes to the school's portable public address system with mixer and speakers. Let's look at each component to understand how they are connected. The Heil microphone has two controls. There is a wide and narrow toggle switch to select the audio bandpass. We use the wide selection. There is a push-to-talk button which will activate the TS2000 transmitter. At the bottom of the mic is a 4-pin XLR connector. This connector provides the push-to-talk feature on a separate pair of wires than the microphone element. This is Heil wire, manufactured for just this application. Notice the two conductors for the push-to-talk and the shielded conductors for the microphone audio. I've built a cable with a 4-pin XLR female on one end that gets plugged into the microphone. And on the other end, there is a 4-pin male connector with a 3-pin XLR male connector in parallel with the mic element. The main transceiver is the Kenwood TS2000. It has an 8-pin microphone connector on the front panel. I made a cable with a 4-pin female XLR on one end and an 8-pin mic connector on the other. The XLR gets connected to the microphone cable. The other end of this cable gets plugged in and is secured using the locking collar. On the rear of the transceiver, we use the 13-pin ACC2 accessory jack for receive audio. The audio is at a fixed level and is not affected by the front volume control. The interconnect cable has a 13-pin connector on one end and a 3-pin male XLR on the other. The cable connects the TS2000 to the mixer. Also on the front of the radio is a headphone jack. The radio operator can use this and the volume control to adjust to a comfortable level. The ICOM IC7000 transceiver is used for backup. We use the HM151 hand mic on this radio. It can be plugged in two different places. Here on the bottom side of the front control panel, or here on the rear of the radio. Either of the two 8-pin modular style connectors can be used. Also on the back of the radio is a 6-pin DIN connector that we use for receive audio. I've made up a cable that has a 6-pin DIN on one end and a 3-pin male XLR on the other. The audio coming out of this jack is at a fixed level and is unaffected by the squelch control or volume control. On the right side of the radio is a headphone jack. This miniature jack is mono, so an adapter is used to provide sound to both ear cups. A professional Shure FP33 microphone mixer is used for the Aris audio setup. This mixer has 3 XLR inputs on the left. These can be configured for either microphone or line level inputs. These inputs are controlled using the volume knobs on the front of the mixer. This is the master volume control, which is set to 0. To the right of that is the headphone monitor control. A VU meter shows the average volume setting of the mixed output. On the right side are the outputs. 2 XLR outputs can be set to either microphone or line level. The headphone connectors are here, which accommodate either an 1/8 inch or 1/4 inch stereo plug. This tape output is an 1/8 inch stereo jack, which we use for recording. The FP33 is powered using 2 9-volt batteries. The batteries will easily run the mixer for over 8 hours. Let's review our audio distribution schematic. There are 3 inputs: the Heil microphone, audio from the TS2000, and audio from the IC7000. Channel 1 is used for the Heil microphone and is set to microphone level. Channel 2 is for the TS2000 main receiver audio and is set to line level. And Channel 3 is for the IC7000 backup receiver audio, also set to line level. During a contact, the event leader and the control operator uses the Heil microphone as a PA microphone without the PTT being depressed.
Our school embraces the fearless sense of adventure and exploration made famous by NASA astronaut John Glenn. He was the first American to orbit Earth and later became the oldest person to fly in space.
During the contact, the control operator uses the PTT button to key and unkey the transmitter. It's important to speak directly into the top of the mic and to speak loudly with good audio pressure. Let's continue reviewing the rest of the components. In order to record the audio of the Aris contact, I use a Sony PCM M10 digital audio recorder. The power switch is held down for a couple of seconds to turn the recorder on or off. The record level control is located on the right side of the unit. The input jacks are on the top. A pair of headphones can be plugged in here. And the headphone volume control can be toggled up or down to adjust the level. There is a USB connector here too. On the front is the main display showing the volume level of record and playback. The controls are easy to operate. Push on the red record button to put the unit into record standby. The pause button blinks until you press it to begin recording. The display will show your recording by counting up the minutes and seconds. The stop button is located here. The recorder is powered by 2 AA batteries and will run for several hours. A mini phone to mini phone cable is used to connect the recorder to the mixer. Plug one end into the tape out on the FP33 and the other end into the line-in jack on top of the recorder. Headphones are plugged into the side of the unit to monitor the audio. The school is providing the PA mixer and speakers. I have several 3-pin XLR extension cables which can be used to send the audio from the FP33 to their system. The FP33 output to the school PA can be either mic or line level. It's possible that noise can get into the sound system from several sources. Usually, it is caused by a ground loop between the ham radio equipment and the school PA system. To help eliminate this, I've made up a couple of isolation transformer cables. Inserting one into the audio line oftentimes eliminates hum or distortion. During the contact, the mixer is used to adjust the audio levels going into the recorder and into the PA system. I like to use the peak reading meter on the digital recorder to do this. The ISS audio from the main receiver is mixed with the microphone audio for the audience to hear. When mixed properly, the control operator, student, and astronaut audio will be at the same levels. The volume of the PA should be tested before the event. When you look at the components and understand how the audio is distributed, it's a simple way to have everyone enjoy hearing the questions and the answers. Thanks for watching.